Hey YouTube, and welcome to the 10th episode of Operating System Development series provided by the Iknow channel. In this episode, we're going to be building a simple and basic shell for our operating system. Hope you enjoyed this series, and let's get started. Ladies and gentlemen, welcome to the 10th episode of Operating System Development series. In the previous episode, I said that this one is going to be about making the shell. So first of all, let me demonstrate in the end of this episode what we're gonna get. So I'm gonna open up a terminal, and then I'm gonna go to the root directory of this project, which is under Documents, and Iknow episode 10. Now I'm gonna type in make, and this starts the operating system. Now as you can see now, I am in a shell script. Notice the blinking cursor there. I have fixed a bunch of bugs that were in the previous episodes. So for example, now if I type in help, this would bring us a bunch of commands that I have created. So for example, we have cmd, which launched a new recursive shell. We have a clear, which clears the screen. We have sum, which computes the sum of n numbers. We have echo, that reprint a given text. We have sort, that sorts the given n numbers. We have a Fibonacci, which prints the first n numbers of Fibonacci. We have GCD, which computes the grand common divisor of n given numbers. And we have exit, which quits the current shell. So let's try them one by one. So for example, if I type in cmd, it says you are already in cmd. A new recursive shell is opened. And you can notice here the 1, which means that I am in level 1. A terminal inside a terminal. If I type in cmd once more, for example, it says 2. Now if I exit this terminal, it says goodbye and back to 1. Back to 0. If I type in exit one more time, it says goodbye and the program halts. I cannot do anything again. Make again. Make. Okay. Now let's see the other instructions. So we have clear, which clears screen, pretty straightforward. We have sum, which computes the sum of n numbers, so let's try it out. It says how many numbers? Well, let's say 5, for example. So I don't know, 5, 4, 99, 54, 3, and the sum is 165. Now let's try out echo. Hello world. I am trying my new shell. Perfect. So it echoed back the content. Let's try it sort. Now sort asks me about the array size, let's say 6. I'm going to give it a 6 random number, so 7, 4, 6, 1, 9, 3. And that's before sorting, so 7, 4, 6, 1, 9, 3. And then it asks me whether I want them to be increasing or decreasing. So I'm going to press 1 for increasing. And as you can see, the numbers are sorted for me. The algorithm that I used here is insertion sort, but you can implement the algorithm you wish. Now we have Fibonacci, so Fibonacci, and it asks me how many numbers, how many elements I want to print, say 8 for example. And it prints out the 8 Fibonacci first numbers, 1, 1, 2, 3, 5, 8, 13, 21, and so on. GCD, for example, and I'm gonna give it, say, 6 numbers, so 10, 5, 20, 50, 60, 70, and the result is 5, so the great common divisor is 5, which is pretty correct. And there's also another command which I haven't added to the help section yet, but it allows you to change the color of the screen. For example, I'm going to type in color, and as you can see here, it says, it gives me the color codes here, so 0 for black, 1 for blue, 2 for green, and so on, and it asks me which text, what is the text color that I want to use. For example, let's use 2, which stands for green. And what is the background color? I'm going to choose white, which is 15. And as you can see now, it's a green text on a white background. You can test out a bunch of other possibilities. So say, for example, black text on a white background, and this looks just like Mac terminal, etc. So now let's dive into the code. Now inside the code here, what I have changed, I've changed a couple of source files. I've changed screen.c. I've added a couple of functions there, and the main difference here is the shell.c file, which represents our shell. So let's start step by step. So I'm going to first open up kernel.c, and this is the main kernel. So the first thing is to install the interrupt service routine, then clear the screen, print a message, and then launch the shell. The shell is included here using the include /shell.h. Now inside that file, I'm going to open it up, include shell, where are you, shell? There you go. And inside it we have only a declaration of one function, which is launch shell, which takes an integer, and that integer actually represents the level of the shell, just like earlier when we opened up a shell inside another shell. Back to the source, so we have the shell.c file, and this is the main shell. Now this is the launch shell function, which takes, we said, n, and the first thing it does is it takes a string of character from it creates a string variable, allocate 20 bytes to it. And that allocate function, we're gonna talk about it later, which is defined in the util header. Now we have a counter here. Okay, so this is a loop. Do while the user has not entered the word exit. So here's what is going on. Each time the loop gets executed, we're going to be printing to the screen the word NIDOS, which is the name of the operating system, and then the level of the shell we are currently on. So we take that n, and then we convert it into a string, and then we print it. And then we close the parentheses and we print that bigger sign. And then we take from the user a string and put it inside the variable ch which we have declared here. Now that ch, which contains the command from the user, we check what command that is. So for example, if that ch is equal to the word cmd, then we're going to be printing you are already in cmd, a new recursive shell is opened, and then we recall the launch shell function once again. It's like a recursive call, so the function calls itself with a bigger with n plus 1. So for example, if n is initially called with 0 in the main program, the next time is going to be calling itself with 1 and then with 2 and then with 3, and then we're printing it here. If you exit the launch shell function, and since it's recursive, it's going to go back to the upper level and so on. If it's not CMD, then we're going to be checking if it's clear. If it's clear, we're going to be clearing the screen. Otherwise, we're going to be checking it. If it's sum, we're going to be calling a function called sum, which we're going to be talking about it later. If not, we're going to check whether it's exit or not. If it's exit, then we're going to print out goodbye. And we're going to go back from the shell script, of course. And of course, this exit will let this while loop terminate, because here we said keep looping until the ch equals exit. So when the user enters exit, we print that message and then we terminate the loop. And of course we go back to the main program and we have nothing to do, so the program will halt. Or if we are in a recursive call, we're going to go back to the upper level of the recursive call. Otherwise, if the string is echo, we're going to be calling a function called echo. Otherwise, if it's sort, we're going to be calling a function called sort. If it's Fibonacci, we're going to be calling a function called Fibonacci, and so on. If it's GCD, we're going to call GCD. Help, we're going to call help. Color, we're going to call function SetColorCode, and so on. Otherwise, if none of these if ch does not equal to one of these, then we're going to be printing a bad command, and then we're going to repeat the loop again. Now these functions are defined here. So sum, for example, prints how many numbers to the screen, and then it gets an integer from the keyboard, put it here inside n, initialize a variable I equals 0, print a new line, and then creates a new array of size n, and then fill that array of n numbers from the user. So it keeps asking the user about input and then adding those elements to the array. And then it calls another function called SumArray, which calculates the sum of all the elements inside the array, put it in S, and then print result, and then convert that result into a string, and then print it out to the screen, and then return to the line. So that's how the sum function works. Now the fill array and the SumArray are pretty straightforward. So this is the fill array, I equals 0. And then for I from 0 to n, print array of I, and then take the number from the user, and then that is gonna fill the array. So it's pretty basic algorithmic thinking, that. And the sum array does exactly the same as this, but instead of taking the element from the user, each time we add the element from array of I to S, to a variable S, which represents the sum. So here it is. I equals 0, S starts from 0 for I, equals 0 till I hits n, keep incrementing I, and each time we take the element number I from the array and we add it to S, and then finally we return the variable S. Now that's the sum function. We have here, which is the sum function. All of these functions are considered as very small programs. So if you'd like to add another program, another command to this operating system, all you have to do is to add a method, a function here, and you add another clause here, else if string equals to the command you wish to use, and then calling to your function. So it's pretty simple and pretty straightforward. Now the echo function simply returns to the screen, takes a string from the user input, and then prints a new line, and then print that string, and then prints a new line. Pretty simple. Now the sort function creates an array of size n, and prints the array size, takes the array size from the input stream, and then fills the array with the same function we created earlier, and then it prints the array before sorting, and then calls insertion sort. From here it takes the order, whether it's increasing or decreasing, and here it does the insertion sort, sends the array and n and the order, whether it's a 0 or 1, and then finally we print out the array. This function, which print the array, is also pretty straightforward. So we do a loop throughout the entire array, and each time we print the element number I. So the insertion sort is a pretty popular and basic algorithm. We loop through the entire array, and each time we save the element number I into an auxiliary variable, and then we create another counter which starts initially from I, and we keep taking that element back. We compare it with the element just before it, keep doing that until we put it in the right place. And in fact, that's why it's called insertion sort. You could search this algorithm on Wikipedia. It's called insertion sort, and it's pretty popular. And here we have Fibonacci is also another basic algorithm, which I don't need to explain here. So take a number from the user input, and then printing the Fibonacci of it. And this is a Fibonacci that checks with 2, and it's here this Fibo is a recursive algorithm. If n is less than 2, returns 1, otherwise returns Fibo of n minus 1 plus Fibo of n minus 2. It's pretty basic. And this is GCD, which computes the GCD of 2 numbers. And we have here GCD that computes the GCD of a bunch of numbers. This one uses the GCD couple here, and it basically creates a matrix, and from that matrix it keeps calculating the GCD of each time it replaces 2 elements with 1 element just down to it until it hits 1 element, then return it. So I'm not going to be explaining this because it has nothing to do with operating system design, but it's just an example of how you could create simple programs inside your operating system to make it rich and functional, just like scientific calculators and stuff like that. This is another function which prints the matrix. I created this function for debugging purposes so that I can check the content of my matrix during the time of making the algorithm. So it's a great idea to create functions that shows you what is going on, since in this environment there's no debuggers or stuff like that. So here we have the set background color. This is the function that changed the background color. So in this function here, we're printing all the color code. Here we're printing this text, and then this text, and then here we're printing all of these text but with different colors. So for example, I'm printing one blue with the color blue, this one with the color green, this one with the color cyan, and so on. And PrintColor is a function that is defined in the header file called screen.h. You can find it over there, declared there and defined in screen.c. And finally, we're taking from the user the colors that he wished to pick, and then we're changing the screen color. Again, this function is also defined in the screen.h, and finally we clear the screen to refresh everything. And here finally we have the help function, which prints out all the help help commands. So for example, I'm gonna add a new help section to integrate the new color. So here I'm gonna call it, well, color, which basically changes the colors of the terminal, or the shell, whatever you want to call it. So anything else? Well, let me check out here. Great. Now I'm gonna show you the exact steps you need to do in order to add another program. Say for example, we'd like to add another program which which well. Let's say another program that takes two numbers and then multiply them together and then print out the sum. So, well, all you need to do is to copy this else if section here, else if section. There you go. And then you type in the name of the command you wish to use. Say, for example, multiply. And then you call a function. Let's call it multiply. And then you create that function down below. So let's just make it above the help. So void multiply. Well, the multiply functions, so here we have print num1, and then we take from the user first number, and then we say num2, and then we take from the user the second number, and then we print the num1 times num2 to the screen. And if we test it out, multiply, num1 say 6, num2 is 23, and the result is 138. Now let's go back to the other programs, the other codes. So we said that we have added a bunch of functions to this util.c. So the first thing I've added here is the int2string function, which takes an integer and returns a string. First thing is it creates a variable ch of type string of size 50, and then it uses this function to convert an integer to a string. But this function, we said earlier that it creates the string reversed. So this one is gonna reverse the string back to make it correct, to make it normal. And the str2int does the exact opposite. It takes a string, a number string, and then it converts it to make it a number. So the algorithm is pretty straightforward. I don't need to explain it. It basically initializes p with 1 and does a loop through the entire string, and then each time it multiplies the number, takes the number and subtract, which is an ASCII code, subtract the letter 0 from it to make it a real number, not an ASCII code, and then multiply it with p, and each time multiply p by 10 since the base we're going to is decimal. And this is the malloc function, which basically you give it n bytes. It creates a variable of an array variable of size n bytes, and then returns the address of that variable. This is the most basic way to implement a malloc function, but again, this is not the best way to do it. In fact, it's a bad way to do it, because the variable here is created in the stack, which means it's created locally, and when you return an address of a local function, it basically gets deleted. Not gets deleted, but it stays there in the stack and could be deleted anytime. Better way to do it is with heap. So we might change it later, but for now it suits our need. We could go with something like this. Okay, and for the screen here, you can notice here that I added a color variable which stores the current color being used in the terminal. And instead of whenever we're gonna clear a line, instead of saving the number 0 here, we're gonna be saving the color. So the elements with an index that is so one even and the other is odd. For the odd, we're gonna be the one that represents the character is gonna be, we're gonna store 0 in it, and the other, which represents the color, we're gonna be always assigning the variable color to it. So if you don't understand how this function works, you could go back to episode 2, I guess, or 2, to episode 2, and I've explained briefly how this function works. Same thing with this function here. Whenever I print a character, instead of the letter OX 0F, which stands for the white color, I've replaced this with the variable color that holds our color. And here this SetScreenColor function, which takes the text color and the background color, it basically takes the background color and then shift it 4 bits to the left, and then combine with it the text color. So this is gonna create a byte. So this is 4 bits, which represents the background color, and 4 bits which represents the foreground color. And this is the global color variable that we defined here. And here we have the SetScreenColor from ColorCode. So this function allows us to take a ready color code and assign the color code to the variable color. We've been able to use the color variable from other files just like that, but I wanted to use a function that does this for me, because this is a little bit the principle of the object-oriented design, the getters and the setters, where you don't, it's better not to use variables in other text files that are not declared in those source codes, those text files. And here we have PrintColor, which basically does exactly the same thing that the print function does, except with a different color. So here we have string ch and text color and the background color. And first of all, we save the current color. We take it from the variable declared on the top color. We save a copy here, and then we change the color. So SetScreenColor to the new colors. We print our text, and then we restore the original color which we saved here in current color variable. Thanks to this function SetScreenColor from ColorCode, we send our color code which we saved there. So these are basically the changes that I made to the source files, and the final thing is the makefile. So in the makefile, I have added basically the source file shell.c and shell.o. So this is the instruction that allows me to compile. So compiler, C flags, and then the name of the source file and the name of the output file. And we basically add it to the object here, and voila, and voila. Well, you could, as I said, you could add a bunch of new methods, a bunch of new little programs to this operating system to make it suits your need. Stuff like calculating, I don't know, integrals and solving matrices. We might do them later, but for now, I think this is great. I think that this is enough. So thank you guys for watching. Don't forget to leave comments, like, share, and subscribe. Do not also forget to check out the GitHub page of the project. I'm going to be uploading the new changes into the project here. github.com/iknowbrainneedles. Also, do not forget to check out the website www.iknowbrain.com. work. There you go. So thank you guys for watching, and see you next time.